In this video, I'm going to be talking about non-right angle trigonometry and simultaneous equations involving quadratic equations. To start, we're going to talk about non-right angle trig, and we're going to be talking about specifically the sine rule. There's two versions of the sine rule. In one instance, we have the angles on top or the sides on top. If the angles are on top, that means we're finding the angle. And if the side's on top, that means we're finding the side. So that's where they're useful on their own behalf. If you end up using the opposite one, it's okay. It just involves a bit more working to get the answer. So to start off, we're going to work with this. Okay, so if I've got a situation, and I might have 30 degrees here, and we might have a length of 12 there, and we don't know what this angle is. We have no idea what that angle is, and we want to find this angle here. So this side length here, excuse me. So when we're solving this, we're going to be using this equation here. We've got sine of 30, which is this angle, and then we use the side that's opposite, and that goes on the bottom. That's going to be equal to sine of theta, and that's going to be the side opposite. Okay, so it's using all the information. We only use two of these because if we have three, that means we've got two equal signs, and it gets really complicated when we start doing that and doesn't actually give us a proper answer. So now we have this, we need to get sine theta on its own. So I'm going to multiply both sides by 11 because this is sine theta divided by 11. When we do that, we're going to have 11 sine 30 over 12, and that's equal to sine theta. To find theta, we need to do the shift of sine. And then everything in this bracket is from up here. And that will give us our theta. When we type that into our calculator, we'll get shift sine 11 sine 30 over 12, and that gives us 27.279, which we will write as 27 degrees to the nearest degree. Okay, and that's our theta. Now we're going to do the same thing, but we're going to be using this form of the sine rule, and that will help us get the side. So say we're given a triangle. We'll have 98 degrees here with 25 centimeters here. We don't know what this side is, but we know this angle is 38 degrees. Okay, so now we'll put that information into this formula. So we know this side length, it is 25, and that goes over the sine of the opposite angle. And then we do the same thing here. We're going to have the length of x, and that goes over the sine of the opposite angle. Now we want to get x on its own, so I'm going to multiply both sides by sine 38. We'll have 25 sine 38 all over sine 98, and that will give us x. Okay, so we don't have to do shift here because we're finding just the side length, and we only do shift when it's an angle. So if we type in, as we see it, 25 sine 38 over sine 98, we get our length of 15.5427, which, if it's say to one decimal place, it's going to be 15.5 centimeters. That's to one decimal place. And that's how we use the sine rule to find either an angle or a side. And we're going to do that same thing, but now we're going to be working with the cosine rule. Now, once again, there are two forms of the cosine rule. We'll use one version when we're solving for a side. So the way we're going to deal with it here is going to look like this. We're going to have c squared equals a squared plus b squared, which is the same as Pythagoras' theorem, but the change is that we're going to take away 2ab cos of c. Okay, that's our one version if we're finding a side. If we're finding an angle, we're going to be working with this. Cos c is equal to a squared plus b squared minus c squared all over 2ab. Okay, there are two instances. This is for a side, this is for an angle. Okay, now that we've got that out of the way, let's actually try and solve some triangles. Now, in a situation with the cosine rule, we need to have what I call like a triad of information. And just like the sine rule, we needed 3 bits of information, but the cosine rule, say we get given a triangle, and we know this, we know this, we know this. That's our triad. We know we've got side, angle, side, all together. So if we had this side, this angle, and this side, it wouldn't work. We need to make sure we've got this triangle, this trinity of numbers, so to speak. Now, if we have that, we can find this unknown. That's the one we can find. We're not going to find either of these angles. We want this unknown. Okay. So if we're going to do that, we're going to use this formula because we're finding a side. We'll first have x squared, because that's what we're finding, is equal to either of these. We're going to have 7 squared plus 9 squared, which is the other, minus 2 lots of 7 lots of 9, cos of the angle in between. Okay, and in order to find our x squared, we type that all into our calculator. So if we were to do that now, we're going to get 7 squared plus 9 squared minus 2 lots of 7 lots of 9 cos 102 degrees. And that gives us this number here, 156.19 with some decimal places. Now that's all well and good, but it's giving us our x squared. We want our x, so in order to get x, we need to square root that solution. So the square root of 156.19, etc., gives us 12.49 with information. Let's say it was just at 1 decimal place, that's 12.5 units, because it's our side length. Now we'll do it again, but this time we're going to be finding an angle. So say we've been given this triangle here. That's our unknown. We know that this is 5, this is 12, and this is 9. Now we've got that trinity over here, plus one opposite. So here we have trinity and something opposite, trinity and something opposite. So we're going to deal with that, but this time, because we're finding an angle, we're going to use this. So it's going to be cos of that angle is equal to one of these. So we're going to do 5 squared plus 12 squared minus that opposite number there, which is 9 squared. That's all over 2 lots of the trinity numbers. Okay, so now we've got that. I'm just going to type that into our calculator, and that will give us cos theta. So we have 5 squared plus 12 squared minus 9 squared over 2 lots of 5 lots of 12. So that gives us 11 on 15. And now we just have to do shift cos, because we're finding an angle of that, and that will give us theta. So shift cos 11 over 15 gives us 42.833, which to the nearest degree is 43 degrees. And that's how we use the cosine rule for both sides and angles. if we're in a situation where we need to find the area of a shape, that is when we need the trinity again. So let's say we've got that same triangle from before, and this time we're using the formula A equals a half AB sine C. Okay, so in this situation we're going to have, say, that triangle from before, so there's 102 degrees, that's 9, that's 7. We've got our trinity. We have our A, which we'll say is 7, our B, which is 9, and then the sine of the angle in between. Okay, now we've got that all there. We just pop it into our formula, into the calculator. So we have our half, lots of 7, lots of 9, sine 102, and the area will be 30.81, which we'll just say to one decimal place is 30.8 units squared. Okay, so using the area rule, quite simple, but we just need to make sure we have that trinity, otherwise we can't use it immediately. We might have to do a little bit of extra work. Say we're in a situation where we have been given the area, but we need to find either a side or an angle. You might have a situation like this. Let's take essentially the triangle that we have there, but we'll remove a bit of information. We have 102 degrees there, we have 7, we have an x here, but we know that the area is equal to 31 units squared. Okay, if we've got that situation, we're going to introduce all of this into our formula. So we have 31 is equal to a half times 7 times x sine 102 degrees. So we have that. We need to get everything that isn't x over here. Okay, so the fastest way to do that, because this is all being multiplied together, is to divide 31 by everything that isn't x. So in this case, I'm going to divide by a half times 7 times sine 102. I'm going to divide both sides by that. By doing that, I'm going to have x left on the right hand side. So that's nice and easy. But on the left, we're going to have 31 over all that information. So it's going to be a half. There'll be a 7, a sine 102. And if we type that into our calculator, we'll get our x value, which, knowing from this triangle here, it'll be roughly 9 if we did it correctly. 31 over 1/2 times 7 times sine 102. There we are, it's 9.055, which, say to the nearest whole number, x is equal to 9 units. Okay. Now we're going to be talking about the sine rule again, but the difference between the sine rule before and now is that we're still finding an angle, but it's obtuse. And when we have an obtuse angle, our calculator is going to give us an acute answer. And when that happens, we need to think about what we're actually doing, whereas opposed to in other instances, we just need to be able to use the formula. So here we're finding an angle, so we know that we need to have our angles on top. So I'm going to do sine of 47, and that's going to be over 12. I'm going to set that equal to sine of theta, which is going to be over 16. We want to get sine theta on its own, so we're going to multiply both sides by 16. So we're going to have 16 sine 47 over 12, and that is going to be equal to sine theta. Now we want to get theta, so we're going to type in all of this with our shift sign because we're finding an angle. And our answer will be shift sign 16 sine 47 on 12, and that gives us theta is 77.19, which to the nearest degree is just 77 degrees, which we're very happy about, except that 77 degrees is less than 90, and we can see visually, and also from a question saying that it might be obtuse, that we need to find the obtuse angle. Okay, now if we're in a situation where we might have this, in order to get our obtuse angle, we need to consider our unit circle, and that all stations to central. In this situation, sine can be positive in both the first and second quadrant. And as it is positive in the second quadrant, that means we'll get a positive angle when it's obtuse. So 77 degrees is about here, say, being that as 77 degrees. And the way that we find the obtuse version of that angle, we need to come in this way, 77 degrees. And to do that mathematically, we need to subtract 180, this from 180. So theta, when obtuse, is equal to 180 degrees minus 77 degrees. And when we do that, we get 103 degrees, which should be our answer. Now, just a way to check that, to make sure that we've done it all correctly, sine of 77 equals 0.974, etc. If they are truly the same, they should result in the same number. And they do in this case, as we can see, both solutions are the same, even though that number there is changing. So, as that's the case, we know that we've done it correctly, and theta is certainly obtuse as it's greater than 90 degrees, but less than 180. Now we're going to move on to simultaneous equations with quadratics. And when we've got that situation, we have to remember what a quadratic looks like and what a linear equation looks like when they're combined. So if we have that situation, so we've got a parabola here, that's a quadratic, and on our plane we might have a line. When we have a line, there's three instances that we can get. We can have, say, this, which might be the most common when asked to do questions about a quadratic, where there is 1, 2 solutions. There can also be an instance where everything works out really well and there is one solution, and that's just there, where it hits the parabola only once. So this is 2 solutions, 1 solution, and of course that leaves where there could be 0 solutions, and that is where a line might miss everything to do with this parabola. So that is 0 solutions. As there are 3 solutions, that's important to remember, because when you're answering and solving, there might be more than one possible solution, or there may be none. So let's just look at a couple of situations where we might have a parabola and a linear. A very simple one to start might be y equals x squared, but y also is equal to, say, 16. Okay. Now, in a situation like this, we can see that y is always 16. So that means we're going to have a horizontal line cutting through a parabola, just like this. So this is a parabola that it looks roughly like y equals x squared, and then at 16 it's going to cross twice. Now we need to find our x values, because we already know our y values. It's going to be 16 in both cases. So the way we do this is we set, as they're both equal to y, we set them equal to each other. So we have x squared is equal to 16. And once we have that, we want to get x on its own without this square, so we're going to square root both sides. So if we square root both sides, we're going to get x is equal to 16. Excuse me. We're going to square root both sides, we're going to get x is equal to 4, which is the square root of 16. However, you'll notice that there's 2 solutions, and we only have one x value here. And that's because when you square root a number, you aren't necessarily sure whether it's a positive or negative number, so we take both. And that's because we've gone across, say, here to 4, and the other way to negative 4, where here we've gone up 16 both cases. So the two solutions that we have is going to be when x is 4, y is 16, and when x is negative 4, y is 16. So there's our two solutions. Okay, that's one instance. Now a second instance that is also quite common might be something like this. Y equals, well, x squared plus x, and the other one might be 2x. There are two equations. Now we're going to, in this case we've got a parabola because there's a power of 2, and in this case we're going to have a straight line on it with a gradient because there is an x. So in this situation they're both equal to y, so we're going to set them equal to each other. X squared plus x is equal to 2x, and we want to get everything to one side. In a situation where there's lots of x's like this, just getting everything to one side makes it easy to work with, because then we can factorize. So we'll do that. We're going to take away 2x from both sides, because then 0 will be left over here. X squared will be the same. Plus x minus 2x is negative x, and that's going to be equal to 0, which was our goal. Now we have that. We can see that there's a common x here. We've got 2 x's here and 1 x here. So if that's the case, I can take 1 out, and we're left with an x from here and a negative 1 from here, and that's equal to 0. Now from here we can actually see what both our x's are, and that takes a bit of practice, but we can see it. We need to make sure that, well, 0, anything times 0 will equal 0, and there's a multiplication going on here, so we know that one of these numbers is going to be 0, either this x or this whole lot of brackets. In this case, well, x is on its own, so x can be 0, because 0 times whatever equals 0. But we also have this instance where we've got this bracket, and if x was 0, 0 minus 1 is negative 1, so that's not going to be 0. But if we make it 1, x is 1, then 1 minus 1 is 0, and 0 times 1 is 0. So that must be our other x value. So now we've got our two solutions. We need to actually see what our y values are. So we can use either of these equations to kind of work from that. I'm going to use this one because it's a bit simpler without any squares. So when x is 0, 2 times 0, that's going to be 0 as well. And when x is 1, 2 times 1 is going to be 2. So they're our two solutions. So we can see both instances we've got two solutions. The last example that we're going to be looking at is a situation where we're going to have to factorize it in a bit more depth. So here we've got two equations. They're both equal to y. We're going to set them equal to each other. That's how we start pretty much any equation that has a quadratic in it. X squared minus x minus 2 is equal to x plus 6. Okay, now we want to get all of this on that side, so I'm going to do it in 2 steps but in one line. So I want to get rid of this x, I'm going to take away x. I want to get rid of this positive 6, so I'm going to take away 6. Doing so, on this side I'm going to have x squared minus x is minus 2x, and minus 2 minus 6 is minus 8, and that's equal to 0. Now that it's equal to 0, we can factorize this, so we can have two lots of factors that, when multiplied, will equal 0. So, the way we do this, there's lots of different ways. The way that seems to be the easiest is the product sum method. Product meaning times, sum meaning addition. The product needs to equal negative 8, product of two numbers, and the sum of those same two numbers need to equal negative 2. Okay. As this number is negative, that means one of the numbers is negative, one is positive, and we need to find two numbers, add to get negative 2, multiply to get negative 8. Now, for most, this can just be a trial and error process, and as you're getting started with this, trial and error is fine. So let's just get some ideas out, and we'll just see what happens. So we know that, well, negative 8 times 1 will give us negative 8, but then if we add them together, we're going to get negative 7, which doesn't work. So maybe we'll go with a different lot. Maybe if we do negative 4 plus 2, we know that when they get multiplied, we're going to get negative 8. If we add them together, we get negative 2. So we've stumbled upon it on our second attempt. Negative 4 and 2 are going to be our two numbers. because negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So it works. Now that we've got that, I'm going to take these two things and I'm going to pop them in brackets with an x. So what I mean by that, we're going to have an x minus 4, and then an x plus 2, because that's a positive 2, and that's going to be equal to 0. Now, the way we know that this will work is if this lot of brackets equals 0, 0 times something is 0, and vice versa for this lot of brackets. We can easily see that if this x is the opposite sign of this 4, negative 4, then we're going to have an x. So for this one, it's going to be just a positive 4, and then this one's going to be a negative 2. There are two options. We can then pop them back into either of these equations to get our y value. I'm going to put it in this one because x plus 6 is simpler than the one above it. If x is 4, 4 plus 6 is going to be 10, so y would be 10. If x is negative 2, negative 2 plus 6 is going to be 4. So that's our y value. So there are two solutions. Now, just a brief side note, how do we know that this is true? Well, if I expand it, I'm going to get this situation. So just to quickly show how that works, we have our x minus 4, x plus 2 equals 0. So I'm going to expand these brackets. We're going to have x times x is x squared, x times 2 is positive 2x, x times negative 4 is negative 4x, and negative 4 times 2 is negative 8. So already we can see that there's our product from up here, because negative 4 times 2 is negative 8. Here we've got an addition going on, 2x plus negative 4. So negative 4x. So 2 minus 4 is going to give us negative 2x minus 8. So you can see that by adding these numbers together we get this via this step, and this number is given straight away by this first step. So that's in reverse what we're doing to get from this to this, and that's why the product sum method is useful. So using these ideas, this is essentially 5.3 in a nutshell for these two concepts, and it obviously goes further than that, but this is just to make sure that we have the basics down so we can achieve in any given situation.